All right, it's July 13th, 2024. This is Synergetics Stream 20.1. Spirit for today, readiness, indication, honesty. Synergetics is participatory. Leave comments, reach out, etc., etc. Today in 20.1, we'll go over some slightly modified key memes and themes and things to integrate, and then go through 3 text sections: 1006, Omnitopology Defined; 536, Interference Domains of Structural Systems; 1210, Numerology. And if you're watching in a live chat, feel free to leave a comment and I'll look at it at the end. Key memes and themes, Synergetics, new edition here, exists for us in namespaces and language games, which is to say forms of life. Some previous key memes and themes, some modified images, and also a new list. Yes, all of those key memes and themes, and people, art, history, archiving, ethnography/ethnography, humanities, cognitive science, philosophy, trim tab/cybernetics, and so more and other. And things to integrate. Brought a few sections that were in the topics to include into what we'll discuss today, and added a few other things. Okay, going right to 1006. Omnitopology Defined, 1006.10. 1006.11. Omnitopology is accessory to the conceptual aspects of Euler's superficial topology in that it extends its concerns to the angular relationships as well as to the topological domains of non-nuclear closest packed spherical arrays and to the domains of the non-nuclear containing polyhedra thus formed. Omnitopology is concerned, for instance, with the individually unself-identifying concave octahedra and concave vector equilibria, volumetric space domains, betweenly defined within the closest packed sphere complexes, as well as with the individually self-identifying convex octahedra and convex vector equilibria, which latter are spontaneously singled out by the observer's optical comprehensibility as the finite integrities and entities of the locally and individually spherically closed systems that divide all universe into all the macrocosmic outsideness and all the microcosmic insideness of the observably closed finite local systems, in contradistinction to the indefinability of the omnidirectional space nothingness frequently confronting the observer. So the big definitional goal of this section is defining what omnitopology is. And right off the bat, Fuller's defining and Applet defining omnitopology as something that's accessory, so not necessarily secondary, more like extension or elaboration on what we might know as topology, which is studying how things are connected. For example, like graph theory with nodes and edges. What else does omnitopology have? It adds in some extra topological considerations that start to verge into the geometric, such as discussing the close packed spheres, the isotropic vector matrix or IVM, and specific polyhedra, which are shapes. And it's concerned with the relationships among the above, for example, related to space fillingness or co-tessellation. Another important idea here is that physical forms are framed in terms of the observer's optical comprehensibility, which is transposing or mapping or interfacing the physicality of the observation to this metaphysicality, kind of cognitive space or ideal space of shape concepts. And so, quite literally, Fuller's talking here about a cognitive partition on a situation. So in active inference, we might think of that like ecosystems of shared intelligence, higher order cybernetics, observer theory. And that partitioning, that cognitive particle situation, is in contradistinction to indefinite fields, like field theories. So in the bottom left, some images of isotropic vector matrix. Here's a vector equilibrium. Close packed spheres. And close packed spheres are the basis of the integer counting features of shape nucleation, and shapes are like finite fragments of this IVM. How do we get around in the IVM? With the quadray. And the quadray coordinates are the IVM native 4D or dimensional measuring tool. It also serves as a mnemonic for the TET. So it's kind of like we're reaching into a space and holding either 4 vectors radiating out of the hand with a quadray, that's like our ruler in the space, or something that looks more like the positive and negative directions of the XYZ quote 3D. 10.6.12. The closest packed symmetry of uniradius spheres is the mathematical limit case that inadvertently captures all the previously unidentifiable otherness of universe whose inscrutability we call space. The closest packed symmetry of uniradius spheres permits the symmetrically discrete differentiation into the individually isolated domains as sensorially comprehensible concave octahedra and concave vector equilibria, which exactly and complementingly intersperse eternally the convex, individualizable phase of comprehensibility as closest packed spheres and their exact individually proportioned concave in-betweenness domains as both closest packed around a nuclear uniradius sphere. That's illustration 1032.30. Or as closest packed around a nucleus-free prime volume domain. Here's a vector equilibria, perhaps via positiva. And here is a concave octahedra and concave vector equilibria, close packing defining the voids. (10.6.13). An interesting section coming up about systems. Systems are individually conceptual polyhedral integrities. Human awareness's concession of space acknowledges a non-conceptually defined experience. The omni-orderly integrity of omnidirectionally and infinitely extensible, fundamentally coordinating, closest packing of uniradius spheres and their ever-coordinatingly uniform radial expandability accommodates seemingly remote spherical nucleations that expand radially into omni-intertangency. Omni-intertangency evidences closest sphere packing and its inherent isotropic vector matrix, which clearly and finitely defines the omnirational volumetric ratios of the only concave octahedra and concave vector equilibria, discretely domaining all the in-betweenness of closest packed sphere interspace. The closest packed sphere interspace had been inscrutable a priori to the limit phase of omni-intertangencies. This limit phase was, and always will be, omnipotential of experimental verification of the orderly integrity of omni-intercomplementarity of the space-time special case, local conceptualizing, and the momentarily unconsidered, seeming nothingness of all otherness. Complex passage, so a few pieces of it. One way to say it is shape is in space, or you can take it more particularly like a shape is in a space, or a shape is in space, or shape is in a space, although combinations of the parentheticals. Another way to say that is that space is like our field-like infinite, indefinite, infinite background concept, which is complementary, not negation, complement, to our discrete, particular, finite figure shape form concept. So it's a figure ground dependent arising. In Synergetics, IVM is the space filled with closest packed spheres. The sphere's radius, and also the double of that, the kissing sphere's distance, which is 2 radii, which is the diameter, the center spanning distance in the IVM. The length can be scaled to different amounts. So it can scale down to a Planck length or lower for physics. It could be atom scale to make material simulations. It could be person scaled for logistics or social synergetics, or it can be in an arbitrary state space. And that rescaling is very useful for rebalancing / staying balanced with integer accounting, which is a little fun play with integrity. Integer addressing is possible with quadrats, in that you can use whole number vectors to get from any sphere center to any sphere center. And then also the shapes or the fragments that are constructed of the IVM have an integer mass. So actual geometry of forms has an integer mass with the right scaling. For example, a point, quadrate coordinate, point 0, 1, 2, 3.5, could be placed at a 10x higher resolution mesh to give 0, 10, 20, 35. It just, the radius is 10 times smaller. So what's kind of cool about generating triangular and tetrahedral mesh is this isn't some flight of Fullerian fancy. Here's a 2017 paper, fast and high quality tetrahedral mesh generation from neuroanatomical scans. And so when we see scanning, that brings to mind SPM. And in fact, in their figure 1, they show SPM as a top neuroimaging tool, subtools, including functional tools related to multi-label segmentation, probabilistic segmentation, and surface modeling. And some of the figures from this paper are really cool, and they give a sense of how and why on a flat surface triangles are used for space filling, and in a three-dimensional surface, four-dimensional surface, however you want to see that kind of space, even the people thinking in terms of XYZ use tetrahedral coordination for mesh drawing and triangles on surfaces. So even without getting into this kind of structural integrity discussion about a triangle versus a square having more structural stability, or a tetrahedra with comparison to a hexahedra cube, even without going into the number discussion, namespace discussion, already the XYZ people are using the tetrahedral approximations. So, interesting. Human awareness is conceptually initiated by special case otherness observability. Humans conceptualize, i.e. image eyes, or image in, i.e. bring in, i.e. capture conceptually, i.e. individualize, i.e. systematize, by differentiating local integrities from out of the total, non-unitarily conceptualizable integrity of generalized universe. So, very Blakean with the minute particulars and the finiteness and particularity of the cognitive setting, and all observation of otherness being a partition from out of the total, and yet at also the same time relating to conceptualizable but not necessarily manifest aspects of the general universe situation. Omnitopological domains. In omnitopology, spheres represent the omnidirectional domain of points, whereas Eulerian topology differentiates and is concerned exclusively with the numerical equatability of only optically apprehended inventories of superficial vertices, faces, and lines of whole polyhedra, or of their local superficial subfacetings, V plus F equals L plus 2, when comprehensive, V plus F equals L plus 1 when local. So here on the omnitopology framing, points not as going the way of dissipating abstractly, like points being zero-dimensional or non-existent. Here, a space enclosing sphere is the point concept. So it's kind of like a thick point, or also perhaps check out the Growth and Deek site and the work of Shanna Dobson on diamonds and the topos and the sheath. 21. In omnitopology, the domains of volumes are the volumes topologically described. In omnitopology, the domain of an external face is the volume defined by that external face and the center of volume of the system. So this is kind of part of the Operation Duck Rabbit way of seeing, on one hand, this alternative kind of geometry, perhaps that's most commonly taught nowadays, which would be like points are zero-dimensional or abstractions. Then you have lines, point to line to plane, kind of Kandinsky, but the school child version. And then you get all the way up to, quote, 3D, and then you can multiply certain edge lengths together. Like for a regular cube, you could just take one side length and take it to the third power. And that is how you compute the volume. Now, in omnitopology, we've already baked volume into the point concept. Nothing is existing that's not space enclosing, so volume is there at the beginning. And so it's this kind of funny sentence like, we're talking about the volume that we're talking about. If you had the nucleation of a bunch of little tiny molecules of metal, and then you shaped it into a cube, yeah, you still could measure the edges of that cube with whatever ruler, and then take the third power, and you would get the volume. Also, you could have counted up how many atoms there were in the mass of the atom. In omnitopology, the domain of an external face is the volume defined by that external face and the center of volume of the system. So this is talking about this concept of a domain. So as always, playing a little bit with namespaces, domain not necessarily here being like the range and the domain of an analytical function, but here domain is in terms of another volume. So we're talking about the domain of a face. It's the volume of the shape going from that face radiating into the volume of the center of the system. So it's kind of like a section of an orange or like a cone that is coming in to the center of gravity of the enclosed system. All systems are enclosed. And then going out to the face. So it's kind of like the mining rights. Like you own the rights to the oil and the resources that are in this cone going down in 22. All surface areas may be subdivided into triangles. We saw that empirically in the neuroimaging data. All domains of external facets of omnitopological systems may be reduced to tetrahedra. That's just the next dimensional analogy, whether you want to think of that as going from, quote, 2 to 3D, or you want to think of that as always having been in 4D. The respective domains of each of the external triangles of a system are those tetrahedra formed by the most economical lines interconnecting their external apexes with the center of volume of the system. And there's a ton to say on this very interesting topic, but that's why it's called a geodesic. So here's like a smooth tent or umbrella. It's a probability distribution from Friston et al. 2024. But let's flip this so that rather than hill climbing, now we have like a bowling ball and we're watching the ball roll downhill, either on a fixed landscape like a skate park, or it could be on like a tarp that is also being modified by the movement. That's also a setting considered by relativity. So the tarp can be fixed, landscape can be fixed, free energy landscape can be fixed, or not. This is called a geodesic as it moves through, and then we use finite structural approximations, and these are the shapes of the curves that are used, for example, in what are called geodesic domes, which is what Fuller's architectural work is very more known for. Now there's going to be some more specific pieces on point to line to plane, so it kind of has that Kandinsky flavor. However, it's going to be done in a different way. In omnitopology, each of the lines and vertexes of polyhedrally defined conceptual systems have their respective unique areal domains and volumetric domains. See section 536. We will go to 536 later. 24. The respective volumetric domains of a system's vertexes. Here for the next 4 I'm not going to read them out loud, but I highlighted the first sentence. 24 is talking about the volumetric domains of a system's vertexes, how that's defined. Then the surface domains of the system's vertexes. Then the areal domains related to area, not flight domains, of external polyhedral lines, and then respective volumetric domains of all lines. So surface and areal being synonyms. Here we have a very interesting structure to move through the 4-quadrant possibility spaces related to surface area and volume. So that's 1006.30 continues on with more on the vector equilibrium involvement domain. So this is more of a specific discussion of the vector equilibria, so maybe for the future. Back home. All right, that was 1006, Omnitopology Defined. Now, as promised, 536.0, interference domains of structural systems. Okay, interesting section. 536.0, interference domains of structural systems. As distinct from other mathematics, Synergetics provides domains of interferences and domains of crossings. In the isotropic vector matrix, the domains of vertexes are spheres and the domains of spheres are rhombic dodecahedra. These are all the symmetries around points. Where every vertex is the domain of a sphere, we have closest rhombic dodecahedral packing. The coordinate system employed by nature uses 60 degrees instead of 90 degrees, and no lines go through points. There are 60-degree convergences even though the lines do not go through a point. The lines get into critical proximities, then twist past one another, and there are domains of convergences. In a polyhedral system, critical proximity interference domains are defined by interconnecting the adjacent centers of an area of all the separate superficial faces, i.e. external areas or openings, strip you might say eyes, surrounding the vertex or crossing. The surface domain of a surface vertex is a complex of its surrounding triangles, a hexagon, pentagon, or other triangulated polygon, see section 1006.20. So that's kind of referencing back to 1006. Here's 536.03. A lot of interesting ideas here. One kind of beating a dead horse while it's down. No lines go through points. This is kind of like core to the Euclidean geometry. It's like, well, not only is a line this series of infinitesimally close points, and axiomatically these things are defined by being like, posit a line going through 2 points or going through 1 point. So it's all about lines going through points. Here, because we're dealing with like embodied finite systems, again here, like connect to actually weaving this with rope or twisting it out of another shape or using metal, things come close and they do clash. Space enclosing means that you can't co-enclose the same space. It's an interesting question why the domains of spheres are rhombic dodecahedra. And here's 536.03 on that next page. Using the concept of domain that was being discussed earlier. And I look forward to seeing what people kind of get from this. But now more into how are interference domains related. 536.11. There are domains of the tetrahedron interfaced, triple bonded, with domains of the octahedron. The domains of both are rationally subdivided into either A or B modules. There is center of volume or gravity of the tetrahedron and the center of volume or gravity of the octahedron, and the volumetric relationship around those centers of gravity is subdivisible rationally by A and B quantum modules. Footnote 5, see section 920. In neat integer whole numbers. I can then speak of these domains quantitatively without consideration of now obsolete superficial face surfaces, i.e. polyhedra. Polyhedra, as many have brought up, defines what shape is by having multiple faces. However, from building these crystals up volumetrically, there's no need to then describe the shape that's revealed and to describe it in terms of faces. And yet, it is a useful metaphysical ideal. Even though the cork is not in the bottle, I can speak quantitatively about the contents of the bottle. This is because it is a domain even though the edge-surrounded opening is uncorked. So we have no trouble topologically considering tensegrity, mensuration, measurement. It is all open work, but its topological domains are clearly defined in terms of the centers of the systems involved having unique centrally angled insideness and surface angle defined outsideness. Okay. Few pieces here. So here's on 4D Solutions Kirby's channel. This was from TrimTab Book Club in February with David Koski going through the Beast modules. It's an awesome video with a lot of embodied mathematics. Here's a bunch of the TrimTabbers talking. And here's breaking that down. Beast, or beats, if you like other words. Then, to really drill into the heart of the beast of the matter, there's the Beast module work and slides of Kirby, who's discussing this sort of particle zoo concept. Particle in the sense of partition. Literally the exact words describing cognitive particles in active inference. And the Beast deck reviews on School Tomorrow. Quickly, I'll just flip through the current state of these slides just to propagate it another way. Cool. (20) Domain of an area. Areas do not have omnidirectional domains. The domain of an area is the area itself. There's a lot of other interesting definitions in this section. I don't think I'll read them all, but you know where to find them. One part that I definitely have a question about. So this is talking about the domain of a line. So now going from a line, what does it mean for it to have a domain? The domains of the vector edges, so one, quote, edge, but it's a vector on a tet or something like that, are defined by interconnecting the two centers of area, two centers of the spheres, of the two surface areas divided by the line with the ends of the line. So it's kind of like the crease of a page. The edge dominates an area on either side of it up to the centers of the areas it divides. Therefore, they, that sounds like the centers of an area, become diamonds or omnidirectionally octahedra. The domains of lines are two tetrahedra, not one octahedron. Okay, but then the very next sentence is, the domains of lines must be two triple bonded tetrahedra, okay, or one octahedron. So I am kind of not even sure. Domain of a point. Looking at a vector equilibrium as unity, 12 round 1, it is all the domain of a point with a volume of 480. So, question for the live chatter slash next time. How do we get 480? I think that's going to be cool. Maybe it will take us into some helpful integer sequences and give a different way of looking at the vector equilibria, and also probably help clarify what is meant here by domain. The domains of points as vertexes of systems are tetrahedra, octahedra, or triangulated cubes, or they could be the A and B modules formed around the respective polyhedra, and that is often where we see A and B coming into play, is padding a polyhedra like another layer, kind of like a coating on a given polyhedra, and then that coating ends up converting it into a different polyhedra. The most complete description of the domain of a point is not a vector equilibrium, but a rhombic dodecahedron. Because it would have to be all space filling, and because it has the most omnidirectional symmetry. The nearest thing you could get to a sphere in relation to a point, and which would fill all space, is the rhombic dodecahedron. So that's pretty interesting, and it is playing with this idea of figure and ground and close packing. So here's where this kind of got me to, is vector equilibria is 12 round 1, so it's like a baseball. So one way to think about the IVM is it's the close packed baseballs. We do need other shapes, though, to fit into the gaps between the vector equilibria close packed. So if we are okay with there being air in between, quote, air, in between the vector equilibria that we've close packed, then that's all good. But then, and there are some very interesting differentials between the vector equilibria and how the A and the B module do help it fill space. So that's kind of like using the simplicity and the at-handness of the vector equilibria, and then needing to co-tessellate it with something else. Whereas here, the argument is the rhombic dodecahedron is kind of like the shape-like representation of a point, because it's space filling on its own. So that's kind of like wild. Like there's one space filling that's a monotessellation with the rhombic dodecahedron, and then there's this co-tessellation with the vector equilibria. A bubble is only a spherical bubble by itself. The minute you get two bubbles together, they develop a plane between them. That's super interesting with like making foam, and then what are the structures that the foam forms. But the kind of spherical bubble is only going to be spherical by itself. As soon as you have, whether it's a big and a small or two equally sized bubbles, they're going to develop new topological and geometric positions. And 50, domain of action. So this is kind of interesting, because domain was being discussed as like, okay, it's this, the mining rights going into the center of the planet. So that's kind of like this cone, like dividing up the shape with these rays coming in. But now domains of actions is seemingly loosening this word domain. Or maybe not. There are critical proximities tensionally and critical proximities compressionally. That is, there are attractive fields and repelling fields, as we learn from gravity and electromagnetics. There are domains or fields of actions. In gases under pressure, the individual molecules have unique atomic component behaviors that, when compressed, do not allow enough room for the accelerated speeds of their behavior. The crowded and accelerating forces impinge upon the containing membrane to stretch that membrane into maximum volume, commensurate with the restraints of its patterned dimension. So that was often visualized or demonstrated with air being pumped into a balloon, and the framework of the balloon. It also relates to that earlier point that earlier Tet, that lines don't go through points. They kind of like come in together at a boomerang angle to each other, have a tussle, and then they head out. So that's kind of like another Tet. And then also this is, from an active inference perspective, the tension and compression, or tensegrity, domains of actions. Here was two ways to think about them. So one is in terms of the efficacy of affordances, like the actual operativity of the affordance. That could be like the causal consequences of action, like propagating out on the Markov blanket, or it could be like actually the proximate recipient of the action, like the stick hitting the drum, and then the drum hitting only the next air molecule. And then there might be another way too, which is thinking about the domain of action as not just being what is the adjacent causal possible, but another adjacency space, like the adjacency of affordances that could have been selected from, or could have been selected from. And then more next time. But that's it for 536. Okay, thanks for all the great comments. I'm just gonna... Let's have a brief comment intermission. Hello, Upcycle Club. Hello, Stroopy. Sorry for being late. Had no idea this was going to happen. I didn't either. Hello, Kirby. Stroopy wrote, in the IVM, every eye looks from a 4 eyes into an 8 eyes and the other way around. Also sometimes described as the co-tessellation of the oct and the tet. Faces are facet eyes. Okay, Kirby, helping with the 480. Let's take a look there. Looking at a vector equilibrium as unity, it is all the domain of a point with a volume of 480. Kirby wrote, 480 times 1/24 equals 20. E.g., cube octa has volume of 480 A's and B's without getting into how many of each. So if we're thinking about the A and B having a volume of 1, then the 20 volume multiplied by 24 gets 480. Upcycle Club. This is awesome. How can we couple this type of work with Active Inference Institute? I don't know. Let's see. Okay. All right. Last section, numerology. So, two things that we'll look at here. First is just the table of contents. Then we will look at just this section 1210.0 numerology. I will just read this multi-page ventilated prose, and then I'll read anyone else's comments / we'll see what arises. But there's just like, it's too story-like to try to intervene, so I just want to do it. But first, looking at the table of contents, this history section kicks off the numerology section. Indigs and a lot of digit play occur. Then Scheherazade numbers, 1001 nights, all these kinds of myths and facts. And that's the numerology section. Okay. Okay. I'm just going to read this section and we'll see what it's about / see what other people say at the end. Historically long perspective suggests it is... Oh no. Okay. historically long perspective suggests it as possible that many of the intriguing yet ineffable experiences which humanity thus far has been unable to explain, and therefore treats with only superstitiously, may embrace phenomena which in due course could turn out to be complexes of physically demonstrable realities which might even manifest generalized principles of universe. For this and similar reasons, I have paid a lot of attention to ancient numerology, thinking that it might contain important bases for further understanding of the properties of mathematics and of the intertransformative structurings and destructurings of the cosmic scenario yclept eternally self-regenerative universe. My intuition does not find it illogical that humanity has developed and retained the demi-sciences of astrology and numerology. Demi because they are only partially fortified by experimental proofs, which nonetheless challenge us tantalizingly to further explorations, within which it may be discovered that generalized scientific laws are indeed eternally operative. Our observational awareness and Newton's proof of the mass attraction law governing the moon's powerful tidal pull on the Earth's oceans, in coincidence with our awareness of the moon's phase periodicities of female humans' menstrual tides, gave the moon's men's months name. To that human blood flow, conceivably there could be many other effects of celestial bodies upon terrestrially dwelling human lives. In the late 1930s, when I was science and technology consultant on its editorial staff with Russell Davenport, then managing editor of Fortune magazine, I found him to be deeply involved with astrology. Russell couldn't understand why I was not actively excited by the demi-science astrology, since the prime celestial data derived from scientific observations. I was not excited because I had no experience data. That taught me incisively of any unfailingly predictable influence upon myself or other Urshans, which unerringly corresponded with the varying positions of the solar planets at the time of the respective human births. While the planetary interpositionings at any given time had been scientifically established, I had no scientifically cogent means for exploring their effect upon terrestrial inhabitants. On the other hand, I found many cogent clues for exploring the ancient demi-science of numerology. Ancient numerologists developed many tantalizingly logical theories, some of which were partially acceptable to formal mathematics, such as enumeration by congruence in modulo 8, or congruence in modulo 10, or in increments of 12. Congruence in modulo 10 seemed obviously induced by the convenience of the human's 10 fingers as memory-augmenting, sequentially bendable counting devices of serial experiences. Their common appendages of 10 fingers each provided humans with natural and familiar sets of experience aggregates to match with other newly experienced aggregates as congruent sets. There was also the popular enumeration system based on modulo 12. Human counting systems of 12 were adopted because the decimal system does not rationally embrace the prime number 3. Since humanity had so many threefold experiences, such as that of the triangle stability or that of the father-mother-child relationships, humanity needed an accounting system that could be evenly and alternatively subdivided into increments either of 1 or 2 or 3. Ergo, congruence in modulo 12 was spontaneously invented. Invention means to bring into novel special case use, an eternal and universal principle which scientific experiment and comprehension may attest to be generalized principles. Etymology means the scientific study of words and their origin. Through etymology, man gave names to their abstract number set concepts. English is a crossbred Worldian language. It is interwoven with Anglo-Saxon, Old German, Sanskrit, Latin, and Greek roots, interspersed with Polynesian, Magyar, Tatar, et al. The largest proportion of English words are derived from India's Sanskrit, which itself embraces hundreds of lesser-known root languages. There are a few words whose origins have thus far defied scientific identification. There are not many of these unidentified root words. Those of unknown origins are classified etymologically as old words. All but one of the world-around words or names for numbers are classified etymologically as old words. The one exception is the name for 5, whose conceptual derivation comes directly or indirectly from root words identifying the human hand. None of the other names for numbers in any of the human languages have pragmatic identifiability with names for any other known physical experience concepts. To accommodate the cerebrations of those who are reflexively conditioned to recount their experience in 12-fold aggregates, that is, congruence in modulo 12, unique names were etymologically evolved for the numbers 11 and 12, as well as for the numbers 1 through 10. In the new world-round accepted computational system of congruence in modulo 10, that is, the decimal system, the numbers 0 through 10 are called cardinal numbers. But the English names 11 and 12, or the French names 11 and 12, or the Germans 11 and 12, likewise are cardinal numbers in the duodecimal system, and their cardinal names are used even when employed in the decimal system. Following 12 in the duodecimal system, the number names are no longer cardinal. They are called ordinal numbers, which are produced by combining 1, 2, or 3 with 10, 13, 14, 15, etc., which are 310 and 410 alliterated in English, French, and German. It is not until 13 is reached that the process of counting ordinally, 3 plus 10, is employed in the ordinal naming of numbers where numbers are communicable by sound. There are, however, number systems based on other pragmatic considerations. Roman numbers constituted an exclusively visual method of tactilely scoring or scratching of a one-by-one exclusively visual experience. When non-literates were assigned to counting items such as sheep, they made one tactile scratch for one visually experienced sheep, and a second tactile scratch at another sheep passed visually, and another scratch as the next sheep passed. The scratch was not a number, it was only a tactile reaction to visual experience. It was a one-by-one, tooth-by-tooth intergearing of two prime sensorially apprehending systems, those of touch and sight. While literate you, in retrospect, could say that you can see 3 scratches, that is reflexively occasioned because you have learned to see groups, and because you have a sound word for a set of 3. But non-literate Roman servants who were scoring did not have to have number words to match with tactile one-by-one scratching. Their one-by-one visually experienced one-by-one passing by sheep. The man doing the scratching did not have to have any verbal number words or set concepts. Those landlords, priests, bankers, or unsolicited protection furnishers who were interested in trading, taxing, or extracting life-sustaining wealth as sheep or wheat productivity alone were concerned with the specific total numbers of scratches and of the total sheep or bags of grain. The ignorant servants had scratchingly matched from these total numbers. They calculated how many sheep or bags they could extract for their taxes, or landlord's tithe, or protectionist fee, or banker's interest, without totally discouraging the sheep herders or farmers' efforts. Pays means land. The shepherds and farmers were known as pagans or paysans, peasants, i.e. land-working illiterates. Because the first millennium AD, Roman Empire's dominating Mediterranean world was so pragmatically mastered by landlords and their calculating priests, it is in evidence that the Roman numerals constituted only a 1-by-1 scoring system in which the V for 5 and X for 10 were tactilely sophisticated supervisors tallying or totaling marks, which graphically illustrated their thumbs angular jutting out from the four parallel packed fingers or digits of the totaler's free hand. On the other hand, the intellectually conceived Arabic numbers were graphic symbols for the name sets of spontaneously perceived number aggregates. The Arabic numbers did not come into use in the Mediterranean world until 700 AD. This was 1,000 years after the Greeks had developed their intellectually conceived geometry. The 700 AD introduction of Arabic numerals into the knowledge monopolized economic transactions of the ignorance and weakening Roman Empire and Mediterranean European world in general occurred under the so-called practical assumption that the Arabic numerals were only economical shorthand symbols for the Roman scratches. To the non-literate 99% of society, it was obviously much easier to make a 3 squiggle than to make 3 separate vertical scratch strokes. But to the illiterate, the symbols did not conjure forth a number name. The earliest calculating machine is the Chinese invented abacus. It is an oblong wooden frame which is subdivided into a large rectilinear bottom and small top rectilinear areas by a horizontal wooden bar. Running parallel to the top of the frame's interior space is further subdivided by a dozen or more perpendicularly strung parallel wires or thin bamboo rods. There are 4 beads strung loosely into each of the wires below the horizontal crossbar, and 1 bead strung loosely above the bar on each wire. Start use of the abacus with all the beads at bottom of their compartments. In this all lowered condition, the columns are all empty. To put the number 1 into the first column on the right, the topmost of the bottom 4 beads is elevated to the horizontal midbar. To put the number 2 bottom beads are elevated to this bar. To put 5 in the first column, lower all 4 bottom beads and elevate the top bead. To enter 9, leave the top bead elevated and push up 4 beads in the bottom section on the first right-hand wire. To enter 10, lower all beads in the right-hand column, both above and below the crossbar. Now elevate 1 bead in the bottom section of the second column from the right. The first 2 right-hand columns read 1 and 0 respectively, which spells out 10. The totaling bead with a value of 5 in the separate compartment at the head of each column permitted the release to inactive positioning at the bottom of their wires of the 1-by-1 elevated bead aggregates. Lowering of all the beads permitted empty columns to occur. Moving of the tenness leftward permitted progressive positioning, which integrated or differentiated out as multiplication or division. To those familiar with its use, the tactile visual patterns of the bead positions of the abacus could be mentally re-envisioned or recalled and held as after-image sets in the imagination, which could be mentally manipulated as columns of so many beads, which read out progressively as successively adjacent columns of so many beads, which, when reaching 5ness, called for the moving up the 1 bead of the totaling head compartment set while releasing the previously aggregated lower 4 beads. To drop into their empty column condition, when an additional 4 beads were pushed upwardly in the column, an additional 5ness accrued. All the beads in the column were lowered, and 1 was entered on the bottom compartment of the next leftward column. As the 2 columns now read as 10, it was easier to enter many columned numbers in the abacus and to add them to multi-columned numbers. This process then permitted multiplication and division as well. When an abacus was lost overboard or in the sands, the overseas or over desert navigator could sketch a picture of the abacus in the sand or on a piece of wood, with its easily remembered columns. These abacus pictures invented the Arabic or abacus numerals to represent the content of the successive columnar content of beads. Obviously, this abacus column imagining called also for a symbol to represent an empty column, and that symbol became the cifra, or in England, cipher, or in American, cipher, or what we symbolize as zero, and much later renamed zero, to eliminate the ambiguity between the identity of the word cipher with the word for secret codes and the word for the empty number, all of which mathematical abacus elaboration became known scoffingly as abracadabra to the 99% non-literate world society and to the temporal power leaders who feared its portent as an insidious disruptor of their ignorance-fortified authority. Because of its utterly pragmatic bias, the Roman culture had no numerical concept of nothing. That corresponds to the abacus's empty column. That is, the idea of no sheep. Was ridiculous. Humans cannot eat no sheep. When the Europeans first adopted the Arabic numerals in 700 AD as shorthand for Roman numeral aggregates, they of course encountered the Arabic cipher, but they had no thinkably identifiable experiences to associate with it. Nothing obviously lacked value. For this reason, the Mediterranean Europeans thought of the cipher only as a decoration signifying the end of a communication in the way that we use the word over in contemporary radio communication. The cipher was just an end, period, just a decorative terminal symbol. It was not until 1200 AD, or 500 years later, that the works of a Persian named Algorismi were translated into Latin and introduced into Europe. Algorismi lived in Carthage, North Africa. He wrote the first treatise explaining how the Arabic cipher functioned calculatively by progressively moving leftward the newly attained 10ness by elevating one bead at the bottom of the bottom section of the next leftwardly adjacent column in the multiplication and the next rightwardly in division. Thus, complex computation could be effected, which had been impossible with Roman numerals. The Arabic cipher had been used for several millenniums in the computational manner, first in the Orient, then in Babylon and Egypt. But such calculations had never before been made in Roman Empire's Mediterranean world. No matter how intuitively a man might have felt about the probable significance of the principle of leverage or about the science of falling bodies, previous to the knowledge of the cipher's capability to position numbers, he could not compute their relative effectiveness values without long multiplication and division. The introduction into Europe of the computational significance of the cipher was an epoch-initiating event. For it made possible for anyone to calculate, and this was the moment in which, for the first time, the Copernicuses and Tycho Brahes and the Galileos and Newtons, the Keplers and Leonardos had computational ability. This broke asunder the Dark Ages with intellectual enlightenment regarding the scientific foundations and technological responsibilities of cosmic miracles, now all the more miraculous as the everyday realizer of all humanity's innate capabilities. When I first went to school in 1899, the shopkeepers in my Massachusetts town asked me if I had learned to do my ciphers, by which keyword cipher they as yet identified all mathematics. Even in 1970, accountants in India are known officially as cipherists. Tobias Dantzig, author of Number, the Language of Science, has traced the etymological history of the names for the numbers in all the known languages of the earth. He finds the names for numbers all classifiable as among the oldest known words. Sir James Jeans said, "Science is the attempt to set in order the facts of experience." Dantzig, being a good scientist, undertook to set in order the experience facts of the history of the language of number names. He arranged them experimentally in their respective ethnic language columns. Juxtaposed this way, we are provided with new historical insights. For example, we learn that if we are confronted with two numbers of different languages, words that we have never seen before, and an authority assures us that one of these words means one and the other means two, and we are then asked to guess which one of them means one and which means two, we will be surprised to find that we can easily tell which is which. One in every language starts with a vowel. Ein, oiden, unes, yet, ahead, and has vowel sound emphasis, while two always has a consonant sound in the front. Dwo, sve, dva, ne, tin, and so forth. And has a consonant sound emphasis. For example, the Irish Gaelic, whose ancestors were sea rovers, say un for one and do for two. These vowel consonant relations hold through into the teens, 11, 12 in English, 11, 12 in French, 11, 12 in German, with vowels for oneness and consonants for two-ness. Despite this dissimilarity in different languages for the names of the same experiences, and despite the unknown origins of the concepts from which all numbers but 5 were derived, the whole array of names for the numbers in different languages makes it perfectly clear that the names given the numbers around the world grew from the same fundamental conceptioning and sound roots. In view of the foregoing discovery, we either have to say that some angels invented the names for numbers and the phonetically soundable alphabetical letter symbols with which to spell them, and wrote them on parchments and airdropped those number name leaflets all around the spherical world, thus teaching world around people the same number names, or we have to say that the numbers were invented by one world around traveling people. However, if we adopt the later possibility, it becomes obvious that no single generation of people could within its lifetime, or in fact within many lifetimes, travel all around the world on foot. For the world's lands are islanded. But one way humans could get around, and in a relative hurry, was by high seas keeping sailboats. It thus becomes intuitively logical to assume that sailors discovered and invented the numbers and inculcated their use all around the world. The Polynesians, we know, sailed all over the Pacific. They probably sailed from there into the Atlantic and Indian Oceans. By riding ever west toward east, roaring 40s, the 40s south latitudes, ever eastward revolving waters and atmospheric winds, which encircle around the vast Antarctic continent. The roaring 40s constitute a gigantic hydraulic pneumatic merry-go-round, which, as demonstrated by world-around single-handing sailors of the 1960s, enables those who master its ferocious waters to encircle the world within only a year's time. The Magellans, Cooks, and Slocums, with slower vessels, circumnavigated in 2 years. In contradistinction to the absolute inability to go all around the world on foot, the circumnavigation of the one ocean world, which covers 3/4 of our planet, makes it obvious that the names for numbers were conceived by sailors. As Magellan, Cook, and later Slocum came to the Tierra del Fuego Islanders, they were surrounded by the islanders, who lived by pillaging passing ships, and must have been doing so profitably for millenniums. To explain their sustained generations in an environment approximately devoid of favorable human survival, except by piracy and salvage, of the world around sailing vessels, funneled through the narrow and incredibly tumultuous waters of the Horn running between Antarctica and South America, with often daily occurring 100 feet high waves cresting at the height of 10-story buildings, their 1,000-ton tops tumblingly sheared off to leeward by 100 miles an hour super hurricanes, avoidance of whose worst ferocities could be accomplished by winding through the Strait of Magellan, whose fish trap-like strategic enticement often lured Pacific Atlantic sea traffic into those pirates' forlorn domain. With 85% of the Earth's dry land and 90% of its people occupying and dwelling north of the equator in the northern or land-dominant hemisphere, and with less than 1/10 of 1% of humanity dwelling in the southernmost half of the southern or wave-dominated Earth hemisphere, there is more and more scientific evidence accruing that sailors have been encircling Earth south of Good Hope, north or south of Australia, and through the Horn, consciously and competently for many thousands of millenniums. All unknown to the 99% of humanity that has been rooted locally to their dryland livelihoods. The European scholars of the last millennium have considered the Polynesians to be illiterate and therefore intellectually inferior to Europeans, because Polynesians didn't have a written history and used only a binary mathematics or congruence in modulo 2. The European scholars scoffed. The Polynesians can only count to 2. Since the Polynesians lived on the sea and were naked, anything upon which they wrote could be washed overboard. The Polynesians themselves often fell overboard. They had no pockets, nor any other means of retaining reminder devices or calculating and scribing instruments, other than by rings that could not slip off from their fingers, ankles, wrists, and necks, or by comb-like items that were precariously tied into the hair on their heads, or by rings piercing their ears and noses. These sea people had to invent ways of calculating and communicating, principally by brain-rememberable pattern images. They accomplished their remarkable patterns in sound, they remembered them in chants. With day after day of time to spend at sea, they learned to sing and repeat these chants, using the successive bow to stern, canoe and dugout, stiffing ribs and thwarts, or rafters of their great rafts. As reminders of successive generations of ancestors, they methodically and recitationally recall the experiences enchantingly taught to them as a successive generation, oral relay system, specifically identified with the paired ancestral parents, represented by each pair of ship's ribs or rafters. When they landed for long periods, they upside downed their longboats to provide dry from rain habitats. The word for roof in Japan also means bottom of boat. Staying longer than the wood life of their hulls, they built long halls patterned after the hulls. Each successive column and roof rafter corresponded with a rib of their long boat. Gradually, they came to carve each stout tree column's wood to represent an ancestor's image. Each opposing pair of parallel columns represented a pair of ancestors, the male on one hand and the female on the other hand. While most Europeans or Americans can recall only 10 or less generations of ancestors, in their chants the Polynesians can recall as much as 100 generations of paired ancestors. And their chants include the history of their important discoveries, such as of specific star to specific star directions to be followed at sea, in order to navigate from here to there. While many of the words that their ancestors evolved to describe their discoveries, okay, we're getting there, have lost present-day identification, they continue to sing these words in faithful confidence that their significant meaning will someday emerge. Therefore, they teach their children, as they themselves were taught, to chant successively the special stories which include words of lost meaning, describing each one of every pair of ancestors. This is why the Vikings had their chants and sagas, and why sailors all around the world chant their shanties, as they heave-ho rhythmically together. Thus too did the Vikings sing their sagas, and the Japanese and Indian sailors their ragas, and the Balinese sailors their gagas, meaning tales of the old people, amongst all these high seas living world dwellers whose single language structure served the 30 million square mile living Maoris, whereas hundreds of fundamentally different languages were of static experience necessity developed, for example by isolatedly living tribes of the exclusively inland dwelling New Guineans. A 19th century sailor shanty goes, 1, 2, 3, 4. Sometimes I wish there were more. Eins, zwei, drei, vier. I love the one that's near. Yet, ni, sam, si. So says the heathen Chinese. Fair girls bereft, then we'll get left. 1, 2, and 3. As complex 20th century electronically actuated computers have come into use, ever improving methodology for gaining greater use advantage of the computer's capabilities, as information storing, retrieving, and interprocessing devices has induced reassessment of relative mathematical systems efficiencies, this has in turn has induced scientific discovery that binary computation, or operation by congruence in modulo 2, is by far the most efficient and swift system for dealing universally with complex computation. In this connection, we recall that the Phoenicians, also as sailor people, were forced to keep their mercantile records and recollections in sound patterns. In contradistinction to tactile and visual scratching, and that the Phoenicians, to implement their world-around trading, invented the Phoenician or phonetic, or word-sound alphabet, with which to correlate and record graphically the various sound patterns and pronunciations of the dialects they encountered in their world-around trading. And we suddenly realize how brilliant and conceptually advanced were the Phoenicians' high seas predecessors, the Polynesians, for the latter had long centuries earlier discovered the binary system of mathematics whose congruence in modulo 2 provided unambiguous yes, no, go, no go. Cybernetic controls of the electronic circuitry for the modern computer, as it had for millenniums earlier, function most efficiently in storing and retrieving all the special case data in the brains of the Polynesians by their chanted programming and their persistent retention of the specific but no longer comprehended sound pattern words and sequences, taught by their successive go-no-go male-female pairs of ancestors. This realization forces rejection of the European scholars' former depreciation of the Polynesian competence, which reversal is typical, in both conceptioning and logic, of the myriad of concept reversals that are now taking place and are about to occur, in vastly greater degree, in the late 20th century academic world. The general education system has not yet formally acknowledged the wholesale devaluation of their formerly held scholarly opinions and hypotheses, but that devaluation is indeed taking place, and is powerfully manifest in the students' loss of esteem for their intellectual wares. All of the foregoing, newly dawning realizations point up the significance of the world-around physically crossbred kinship of the world's one-ocean sailors, whose Atlantic, Pacific, and Indian waters were powerfully interconnected by the Antarctic encircling roaring forties. Polynesians, Phoenicians, Venetians, Frisians, Vikings, pronounced Vikings by the Vikings, all alliterations of the same word, all evolved from the same ancestors. The sea was their normal life, and since 3/4 of the Earth's surface is covered in water, normal life would mean living on the sea. The Polynesians spontaneously conceive of an island as a hole in the ocean. Such conceptioning of a negative hole in experience brought about their natural invention of a symbol for nothing, the zero. This is negative space conceptioning, and is evident in the Maori paintings. What is a peninsula to land people is a bay to them. The Maori also look at males and females in the reverse primacy of the land-stranded Western culture. 75% of the planet is covered by the sea. The sea is normal. The male is the sailor. The male is normal. The penis of the normal sea intrudes into the female land. The bay is a penis of the sea. The females dwell upon the land. To the landsmen, the peninsula or penis juts out into the ocean. On the Indian Ocean side of Southeast Africa, the Zulus are linked with this round-the-world water sailing. They are probably evolved from the Polynesians of long ago, swept westward by the monsoons. I found some of the Zulu chiefs wearing discs in their ears, upon which the cardinal points of the compass were clearly marked. The long ears on Easter Island had their ears pierced and stretched to accommodate their navigational devices. Many of the items which European society has misidentified in the Fijis as superstitious decoration were, and as yet are, navigational information storing devices, being stored, for example, as star pattern combs in their hair, or as rings around their neck, or as multiple bracelets, mounted on their 2 arms and legs, and multiple rings upon the 4 fingers of their hands. They had 13 columns of slidable counters, 1 neck, 8 fingers, 2 arms, 2 legs. Most of the earliest known abacuses also have 13 columns of ring bead counters, which became more convenient to manipulate and retain when rib-bellied ships supplanted the open raft and catamaran. Once the mathematical conceptioning of sliding rings on 13 columns had been evolved by the navigators, traders, magicians, it was no trick at all to reproduce the 13-column system in a wooden frame with bamboo slide columns. By virtue of their ability to go from the known here to the popularly unknown there, the navigators were able to psychologically control their local island chieftains. If a chieftain needed a miracle to offset diminishing credit by his people, he could confront them with his divine power by exhibiting some object they had never seen before, because it was non-existent on their particular island. All the chieftain had to do was to ask the navigators to exercise their mysterious ability to disappear at sea and return days later with an unfamiliar object. But the navigators kept secret their mathematical knowledge of offshore celestial navigation and the lands they thus were able to reach. To the landed chieftains, the seagoing navigators were mysterious priests. The South Seas navigators lived and as yet live absolutely apart from the chieftains and the tribe. The priests taught only their sons about navigation, and they did so only at sea. A new era dawned for humanity on our planet when the Polynesians learned how to sail zigzaggingly to windward into the prevailing west to east winds, able to sail westward, able to follow the sun at far greater sustainable all day and all night, day after day, sailing speeds than those attainable by paddling or rowing into head seas, having for all time theretofore drifted in a predominantly eastward wind-blown directions, or gone aimlessly where ocean currents bore them, yielding to the inevitable from west to east elements, bearing them to the American west coasts and to all the Pacific islands throughout the previous X millions of years. Whereas the southern hemisphere ocean was dominated by the west-east roaring 40s. The Polynesians, when entering the northern hemisphere, were advantaged not only by their ability to sail into the wind, but also by the east-west countercurrents of the tropical westward trade winds, which they discovered and called so because they made it possible to go back where man had previously been, and thus to integrate world resources. Thus, the secretly held navigational capability and knowledge of the elemental accounting and astronomy went westward from Polynesia, throughout Malaysia, and to southern India, across the Indian Ocean to Mesopotamia and Egypt, and thence into the Mediterranean. The powerful priests of Babylon, Egypt, and Crete were the progeny of mathematician navigators of the Pacific, come up upon the land, to guide and miracleize the new kings of the Western worlds. Knowing all about boats, these navigator priests were the only people who knew that the earth is spherical, that the earth is a closed system, with its myriad resources chartable, but being water people, they kept their charts in their heads, and relayed the information to their navigator progeny, exclusively in esoterical, legendary, symbolical codings embroidered into their chants. But some of their numbers also sailed deliberatively eastward, carrying their mathematical skills to West Coast America. The Mayans used base 20 in their numerical system by counting with both their fingers and toes. The number 20 often occurs in a magically strategic way. For example, we can look at symmetrical aggregates of progressively assembled spheres, closest packed on a plane, a pool table. First take two balls and make them tangent. Tangent is the closest that spheres may come to one another. We may next nest a third ball in the valley between the first tangent two. Now each of the three spheres is tangent to two other, and none can get closer to each other. The three make a triangle, there is no ball in the center of the triangular group. We can now add 3 more balls to the first 3 by arranging them tangentially in a row across one edge of the first 3's triangle. As yet, all 6 balls are arranged as outside edges of the triangle. Not until we add a 4th row of balls nested along one edge of the triangular aggregate does a single ball become placed as the nuclear ball. In the center of the triangular pattern ball pool table array, 10 is the total number of balls. In this first nuclear ball containing triangle, 9 surround the nuclear 10th ball. And since a triangle is a fundamental structural pattern, and since the triangular aggregate of 9 balls around a nuclear one is a symmetrical array, man's intuitive choice of congruence in modulo 10 may have been more subtly conceived than simply by coincidence with the 10 digits of his hands. We will now see what happens experimentally when sailors stack coconut or orange cargoes, or when we stack planar groups of triangular aggregates of spheres on top of one another in such a manner that they will be structurally stable without binding agents. First, we will nest 6 balls in the closest packed triangular planar array. On top of the first triangularly arranged 10-ball aggregate, and on top of those 6 balls, we can nest 3 more. We now have a total of 19 balls. We may now nest 1 more topmost ball in the one nest of the 3-ball triangle. We now have a symmetrical tetrahedral aggregate consisting of 20 balls without any nuclear ball occurring in the center. Of the symmetrical tetrahedral pyramid of balls, we began our vertical stacking with a symmetrical based triangle of 10 balls. And now we have a tetrahedron composed of 20 balls. Just as fingers alone may not have been the only reason for the choice of base 10, fingers and toes together may not have been the only reason that the Mayan priests chose congruence in modulo 20. Or that 20 was considered a magical number. It might have been the result of an intuitive understanding of close packing of spheres, which is something much more fundamental, for unlike our fingers which lie in a row, the packing of 20 spheres that can be grouped symmetrically together without a nucleus is a fundamentally significant phenomena. In a tetrahedron composed of 20 balls, there is no nucleus. This may be why 20 appears so abundantly in the different chemical element isotopes, and 20 is one of the magic numbers in the inventory of chemical element isotopal abundancy in universe. In order to position a nuclear ball in the center of a symmetrical tetrahedral pyramid of balls, we need to add another or 5th nested layer of 15 balls to one face of the tetrahedron of 20. The total number of balls is then 35, of which 1 is the nuclear ball. However, if we add 4 progressively larger triangular layers of balls to each of the 4 triangular faces of the 20-ball, no nucleus tetrahedron, it will take exactly 100 more balls to enclose the 20-ball no nucleus tetrahedron. This makes a symmetrical tetrahedron of 120 balls. This symmetrical tetrahedron is the largest symmetrical assembly of closest packed spheres nowhere containing any 2-layer covered nuclear spheres. That is experimentally demonstrable. In the external affairs of spheres, such omnidimensional spherical groupings of 120 same-size balls without a nucleus ball can be logically identified with the internal affairs of individual spheres, wherein we rediscovered the 120 least common denominator right spherical triangles of the sphere, which are archaeologically documented as having been well known to the Babylonians, come out upon the land, ocean, navigator, high priest, mathematicians. The number 120 also appears as a magic number in the relative abundance hierarchy of the chemical element isotopes of universe. The 120 accommodates both the decimal and the duodecimal system, 10 multiplied by 12. The Mayans too may have understood about the tetrahedral closest packing of spheres. They probably made such tetrahedra with symmetrically close packed stacks of oranges. The 20th century fruit store man spontaneously stacks his spherical fruits in such closest pack stacking and nesting arrays. But the physicists didn't pay any attention to the fruit store man until 1922. Then, for the first time, physicists called the tetrahedral stacks of fruit closest packing of spheres. For centuries past, the numerologists had paid attention to the closest packing of spheres in tetrahedral pyramids, but were given the academic heave-ho. When in the mid-19th century, physicists abandoned the concept of models. We have seen that there are unique or cardinal names for the concepts 1 through 12 in England and Germany, and for the concepts 1 through 16 in France, but that after that, they simply repeat in whatever congruence modulos they happen to be working. The Arabic numerals, as well as their names, are unique and standalone, only from 0 through 9. However, 11 is a result of two ones, 11, and 12 is similarly fashioned from two previously given symbols, namely 1 and 2, 12. But certain numbers, such as prime numbers, have their own cosmic integrity, and therefore ought to be integrally expressed. What the numerologist does is to add numerals horizontally, 120 equals 1 plus 2 plus 0 equals 3, until they are all consolidated into one integer. Numerologists have also assigned to the letters of the alphabet corresponding numbers. A is 1, B is 2, C is 3, etc. Numerologists wishfully assume that they can identify characteristics of people by the residual integer derived from integrating all of the integers, which integers they speak of as digits, identifying with the fingers of their hand, that is, their fingers, corresponding to all the letters in the individual's complete set of names. Numerologists do not pretend to be scientific. They are just fascinated with the correspondence of their key digits, with various happenstances of existence. They have great fun identifying events and things and assuming significant insights, which from time to time seem well justified. But what games numerologists choose to play with these tools may or may not have been significant, possibly by coincidence, however, and possibly because of number integrity itself. Some of the integer integrating results are found to correspond elegantly with experimentally proven physical laws, and have subsequently proven to be infinitely reliable. Half a century ago, I became interested in seeing how numerologists played their games. I found myself increasingly intrigued and continually integrating digits. And the next section goes into the digit integrity, but that is all for today. Okay, I'm going to look to the live chat. The tetrahedra with the volume of 20, that was interesting. Okay. Stroopy wrote, as I'm leaning my phone on a beaded structure of 4 closest drawn vector equilibria, I can attest to the fact that they naturally grow their complementary gaps as both 1 frequency 8 eyes and hollow 2 frequency 8 eyes. Thank you, Mills8102. Okay, I'll wait one more minute if anyone has any last thoughts or questions. Okay. So that was 20. Lots of fun. Thank you, Kirby. Thank you, Upcycle Club. Yeah, I'd like to collaborate with anyone who wants to work on these slides or other slides, or do some synergetics. People are welcome to meet with Kirby and I as we weave into the XYZ IVM computational space. Yeah, there were so many. Kirby wrote, very good anthropology in my view. Yeah, it's interesting. Like, every sentence or expression has to be like evaluated, and there's some amazing through lines in the discussion that are total incredible insights. Okay. All right. So please feel free to leave a comment, and let's see where we get for 21 and all the other things we can do. So, bye. Thank you.